hopefully you've had a chance to try this problem. I'm going to work through the solution now. So we're looking at fireworks, right? Um, and so the bright red color in fireworks, when you see that, is usually due to strontium nitrate. And it's the emission of light that strontium gives off, the +2 ion of it, when it's heated. And that light color has a wavelength of 650 nanometers, roughly. So the question is asking us, what is the frequency of light? And so I know that the wavelength is 650 nanometers, and I want to know what the frequency is. So I can relate these two variables to one another using the equation that the speed of light is equal to the wavelength times the frequency. So to solve for frequency, I would divide both sides by the wavelength, and I'll get frequency is equal to the speed of light divided by the wavelength. So in this sense, it's a pretty straightforward application of this equation. The only thing that is going to be tricky is the units on the speed of light and our wavelength. The speed of light, remember, is equal to 3.00 times 10 to the 8th meters per second. And so our wavelength units are in nanometers. Oops, sorry. So we have to do a conversion to get these in the same units. And I typically convert into meters personally. That's just kind of the way I do it. And so remember, we have in our metric system, 1 meter is going to be equal to 10 to the 9th nanometers. So setting up my equation, I'm going to set my frequency equal to the speed of light, which is that 3.00 times 10 to the 8th meters per second, and divide that by my 650 nanometers converted into meters. And so I'll multiply this by a conversion factor that has meters on top and then nanometers on the bottom. And you might choose, instead of thinking of this conversion factor as 1 meter is 10 to the 9th nanometers, that 10 to the negative 9th meters equals 1 nanometer. And these are both, they work fantastic. They're the same exact definition. I personally just always think of the base unit as the one that's 1 when we're going smaller, but that's just me. All right, so plugging this into an actual calculator will give me a value that is 4.6 times 10 to the 14th. And my units here are 1 over a second, or I can write that as seconds to the negative 1. I could also write that as hertz as well, or I could write that as 1 over a second. And if I wanted to report this in something that might be a little bit more familiar, like gigahertz, then I would do a conversion where I have, let me change pen color, my 4.6 times 10 to the 14th hertz times 1 gigahertz divided by 10 to the 9th hertz would equal 4.6 times 10 to the 5th gigahertz, however you want to report that.